The universe has a way of hiding its most profound secrets in the plainest of colors. When we look up at the night sky, we are conditioned to seek the pale blue of a potential Earth, or the rusted ochre of a desert world like Mars. Yet there is a hue we have long ignored, a sulfurous, searing yellow that may represent an entirely new category of existence. 35 light-years away, in the direction of the southern constellation Volans, a small M-dwarf star burns with a cool, steady intensity, and tucked within its tight gravitational embrace is a planet that defies every planetary model we have ever constructed. This is L98-59d, a world that should not exist by the laws of our solar system, yet it sits there, shimmering with a strange, toxic brilliance. It is a world where the very concept of an ocean has been rewritten, replacing the life-giving properties of water with the molten, suffocating chemistry of elemental sulfur. To understand L98-59d is to accept that our definition of a habitable zone is perhaps too narrow, and that the cosmos is far more creative in its destruction than we ever dared to imagine. Imagine for a moment the distance that breaks our brains. 35 light-years sounds intimate in the grand tapestry of the Milky Way, a mere stone's throw in a galaxy 100,000 light-years across. And yet, this distance represents a journey of over 200 trillion miles. A gap so vast that the light reaching your eyes tonight from that star began its trek across the void decades ago. It traveled through the near-total absence of everything, passing through the bone-chilling cold of interstellar space, only to arrive here and tell us a story of a world that is fundamentally alien. We often think of exoplanets as variations on a theme, gas giants like Jupiter, or rocky barrens like Mercury. But L98-59d suggests that we are still just babies in our understanding of planetary evolution. It is a world caught in a transitional state, a place where the heat of its parent star has stripped away the lighter elements, leaving behind a heavy yellow shroud. As we settle into this nightly ritual of exploration, we must first look at the yellow paradox. In our human experience, yellow is the color of the sun, of spring flowers, and of warmth. But in the context of L98-59d, yellow is the signature of a planetary-scale chemical factory. Initial data from our most advanced space telescopes suggest that this planet is not just hot. It is chemically saturated in a way that creates a global sea of molten sulfur. This isn't a world with a few volcanic vents or local mineral deposits. It is a world where the geology and the atmosphere have merged into a singular, flowing nightmare. If you were to stand on its surface, though no human ever could, you would see a horizon that doesn't shimmer with the blue of a scattered sky, but glows with a dull, heavy amber. The air would be thick, a pressurized soup of volcanic gases, pressing down with the weight of a deep terrestrial ocean. This is the kind of discovery that makes us realize we are still just making steam when it comes to our technological reach. We build these incredible machines, these glass eyes in the dark like the James Webb Space Telescope, and they reveal truths that make our previous theories look like children's drawings. For decades, we looked for water worlds, planets covered in deep global oceans of H2O. We hypothesized about lava worlds, where the surface is a constant tectonic wound. But L98-59d introduces a third contender, the sulfur world. It is a new class of planet, one that exists in the high-temperature gutter between a rocky Earth-like planet and a gaseous Neptune. It is a world that has been baked, not until it was dry, but until its very crust began to liquefy into something exotic. The paradox lies in its stability. Usually, such a volatile atmosphere would be stripped away by the stellar winds of its red dwarf host. Red dwarfs are notorious for their temperamental nature, frequently lashing out with flares that can sterilize a planet in hours. And yet, L98-59d remains cloaked. It holds onto its yellow shroud with a gravitational tenacity that suggests a massive, dense core. It is comfortably terrified by its own sun, huddled so close that its year lasts only a few Earth days, yet it persists. This persistence challenges our understanding of atmospheric escape and planetary survival. It forces us to ask, how many other yellow worlds are out there, hiding in the glare of their stars, waiting for us to develop the eyes to see them? When we peek under the kilt of the data, we find a planet that is roughly 1.5 times the size of Earth, but with a density that hints at a heavy metal heart. This is not a fluffy gas world. It is a solid, thrumming entity that has been transformed by its environment. The sulfur isn't just an impurity here. It is the dominant feature, the primary solvent, the very blood of the planet. On Earth, sulfur is a byproduct of life and geology, a pungent reminder of the world's internal heat. On L98-59d, sulfur is the landscape. There are mountains of crystalline yellow, plains of jagged brimstone, and rivers that flow with the consistency of syrup, glowing with a faint internal heat as they move toward the great molten basins. As you listen to the rhythmic pulse of this narrative, let your mind drift to the sheer scale of this transformation. We are talking about an entire globe undergoing a chemical transition that we can barely replicate in a lab. It is a cosmic joke of sorts that a world could be so similar to ours in size and yet so utterly terrifying in its composition. We are stardust in our veins, but that star stuff can be assembled in ways that result in a paradise or a hellscape. L98-59d is a reminder that we are the exception, not the rule. We live on a world of water and oxygen, a fragile blue marble in a sea of darkness. But out there, the darkness is filled with yellow giants and amber oceans. The study of this planet is not just about cataloguing another rock in the dark. It is about the stupid filter, that great civilizational hurdle that asks if we are smart enough to understand the universe before we are consumed by our own limitations. By studying L98-59d, we are learning about the limits of chemistry and the variety of planetary fates. We are seeing what happens when a planet is pushed to the edge of its thermal limit. It doesn't always just become a dead rock. Sometimes it becomes something new. It becomes a sulfur sea, a testament to the fact that the universe never runs out of ways to surprise us. Tonight, as we journey deeper into the mechanics of this world, we aren't just looking at a distant point of light. We are looking at a mirror of what is possible when the laws of physics are allowed to play out to their most extreme conclusions. Take a deep breath and let the reality of this yellow paradox settle into your thoughts. We are just beginning to scratch the surface of the celestial clockwork, and the gears we are finding are made of a material we never expected. Under the light of a cool red sun, the sulfur sea waits, a silent sentinel in the southern sky, beckoning us to rethink everything we thought we knew about the color of home. We have always been told that for a planet to be active, it must look like Earth, blue, marbled, and breaking with water. But 35 light-years away, there is a world that suggests the most violent places in the cosmos are actually the most stable. To find it, we must travel toward the southern constellation of Volans, where a small, bright M-dwarf star known as L98-59 anchor, a system of worlds that, until very recently, seemed almost predictable. For years, our telescopes mapped this neighborhood as a collection of terrestrial rocks, categorized simply as planets A, B, and C. They were seen as the standard building blocks of a solar system, dry, silent, and familiar in their rocky composition. We viewed them through the lens of our own history, assuming that a world of this size and proximity to its star would follow the well-trodden path of a super-Earth or a miniature Venus. But as our instruments grew more sensitive, a fourth sibling emerged from the data, and it carried a secret that would fundamentally shift our understanding of planetary chemistry. Planet D is not the rocky shell we expected. When the light from its parent star filtered through the thin veil of this planet's perimeter, the spectroscopic signatures didn't return the expected signs of nitrogen or CO2 alone. Instead, they revealed something far stranger: the distinct, pungent fingerprint of sulfur. This is the sulfur secret of L98-59d. It is a world defined not by blue oceans of water, but by a molten yellow-orange sea of liquid sulfur, constantly replenished by a staggering degree of volcanic outgassing. Imagine a horizon where the sky is a bruised shade of amber, and the very ground beneath you is a shifting, viscous tide of elemental brimstone. This world challenges the very definition of what makes a planet alive, in a geological sense. While Earth uses the movement of water and tectonic plates to recycle its nutrients, L98-59d uses the violent churn of its molten interior to paint its surface in shades of gold and ochre. By the end of this journey, we will understand how this strange neighbor redefines the habitable zone, and why the chemistry of life might not be strictly limited to the carbon and oxygen cycles we find so comforting. We are standing on the edge of a new class of world, a sulfur world, that forces us to ask how a planet so close to its star can maintain such a thick, toxic atmosphere without being stripped bare by the solar wind. The survival of this thick, yellow veil is a defiance of everything we understood about planetary evolution in the inner circles of a star system. Traditionally, a world as close to its host as L98-59d should be a skeletal remain, a scorched marble of bare rock stripped of its lighter elements by the relentless pressure of stellar radiation and the abrasive touch of the solar wind. We have seen this happen elsewhere, where the high-energy ultraviolet light from a star hits the upper atmosphere, breaking apart molecules and giving the resulting fragments enough speed to escape the planet's gravity forever. Yet, here stands a world that has not only held onto its gas, but has compressed it into a dense, high-pressure shroud that would crush a human explorer in moments. To understand how this sulfurous shell remains intact, we have to look at the violent internal metabolism of the planet itself. It is likely that L98-59d is not merely holding onto an ancient atmosphere, but is actively and aggressively outgassing new material from its interior to replace what is lost to space. This is a world in a state of constant volcanic resurrection. Imagine a crust that is less of a solid floor and more of a fractured sieve, where the immense tidal forces exerted by the nearby star knead the planet's core like dough. This gravitational stretching and squeezing creates a staggering amount of internal friction, heating the mantle to a liquid state and forcing molten rock and gas toward the surface. In this environment, volcanoes do not just erupt, they scream. They pump vast quantities of sulfur dioxide and hydrogen sulfide into the sky at a rate that outpaces the stripping power of the star. It is a brutal thermal equilibrium. The star tries to blow the atmosphere away, and the planet simply bleeds more. This creates a specialized environment where the chemical makeup of the air is dictated by the belly of the beast rather than the nebula from which it was born. This constant replenishment suggests that the yellow paradox is actually a sign of a geologically hyperactive world, one that might resemble a scaled-up version of Jupiter's moon Io, but wrapped in a pressurized envelope of gas. The density of this air serves as a protective barrier in its own right, as the lower layers are shielded by the sheer weight of the upper clouds. The sulfur compounds are particularly effective at absorbing and scattering light, creating a self-shielding effect that prevents the star's most destructive rays from reaching the deep interior. It is a heavy, sluggish circulation. This leads us to wonder if this cycle of loss and rebirth is a closed loop, or if the planet is slowly consuming itself from the inside out to maintain its external appearance. If the sulfur is the blood of this world, we are witnessing a planet that is slowly bleeding out into the vacuum, yet manages to look vibrant and full from our distant perspective. But this replenishment cycle does more than just maintain volume. It creates a complex, tiered weather system where the very chemistry of the air changes as you descend through the haze. Which leads us to a question science is only beginning to ask. Does the sulfur cycle on this world mirror the water cycle we know on Earth? And what does that mean for the possibility of a truly alien form of biology? On Earth, the movement of water is the fundamental rhythm of existence, a gentle sequence of evaporation, condensation, and life-giving rain that we have come to define as the baseline for a habitable planet. But as we peer into the toxic, shimmering haze of L98-59d, we are forced to confront a much darker, more industrial version of this terrestrial heartbeat. Here, the role of water is played by sulfur, a versatile and reactive element that creates a closed-loop system of startling complexity. Imagine a sky where the clouds are not composed of harmless water vapor, but of concentrated sulfuric acid and elemental sulfur particles, suspended in a permanent golden twilight. Instead of the refreshing scent of a summer storm, the atmosphere would carry the sharp, pungent bite of volcanic gases, a constant reminder of the planet's violent internal chemistry. This sulfur cycle begins deep within the molten interior, where immense pressures force sulfur dioxide and hydrogen sulfide through the crust in a process of constant outgassing. As these gases rise into the upper atmosphere, they are bombarded by the intense ultraviolet radiation of the nearby star, triggering photochemical reactions that transform them into solid sulfur aerosols. These particles eventually become heavy enough to fall, not as delicate snowflakes, but as a burning yellow grit that settles onto the obsidian-like plains below. On the day side, where temperatures soar, this fallen sulfur doesn't remain solid for long. It melts and evaporates, rising once again to join the high-altitude haze. It is a weather system that operates with the cold, efficient logic of a chemical refinery, moving mass and energy across the globe without ever needing a single drop of liquid water. This realization brings with it a profound sense of cosmic vertigo, a dizzying shift in perspective that challenges our most basic assumptions about what a world can be. For centuries, we have searched for Earth-like planets, subconsciously equating the presence of water with the presence of possibility. We have looked for our own reflection in the stars, assuming that any biology must necessarily share our specific chemical heritage. Yet L98-59d suggests that nature is far more imaginative than our definitions allow. If a planet can maintain a stable, complex cycle using sulfur as its primary medium, could a form of life emerge that views a water-rich world like Earth as a frozen, inert wasteland? In this alien biochemistry, sulfur might serve as the backbone for molecular structures, or as a way to store and release metabolic energy in a high-temperature environment. We are forced to consider a biology that breathes volcanic exhaust and thrives in the heat of a planetary furnace. A life form so fundamentally different from our own that we might not even recognize it as alive at first glance. It is a humbling thought to realize that our definition of a habitable zone might be dangerously narrow, a tiny sliver of reality that ignores the vast, glowing possibilities of the sulfur worlds. We are merely one data point in a universe that seems to delight in breaking every rule we try to impose upon it. And yet, even as we struggle to comprehend a world so utterly foreign, we find a strange kind of peace in the knowledge that the universe is far more crowded with mystery than we ever dared to imagine. As we move closer to the surface of this molten sea, we must leave our earthly biases behind and prepare to see the cosmos through a different, more ancient lens. To find this ancient lens, we need only look 35 light-years away toward the southern constellation of Volans, the flying fish. In the vast, expanding architecture of our galaxy, 35 light-years is practically our front porch, a distance so intimate that the light leaving that system today will arrive here well within a single human checkout. Yet, for years, this neighbor remained a ghost. We knew something was there, a faint red dwarf star labeled L98-59, but the planets dancing in its crimson glow were nothing more than blurry silhouettes, mathematical whispers caught in the peripheral vision of our most sensitive instruments. It wasn't until the James Webb Space Telescope turned its golden eye toward this sector that the silhouettes began to take on the terrifying and beautiful dimensions of reality. This system is a masterpiece of orbital clockwork, a family of worlds labeled A, B, and C, each huddled close to their small, temperamental sun. But it is the architecture of their movement that reveals the secret of Planet D's violent nature. These worlds exist in a state of orbital resonance, a celestial tug-of-war where they pull and push on one another with rhythmic precision. As they pass each other in the dark, their gravity ripples through the neighboring worlds, creating a tidal heating that fuels the molten interior of Planet D. It is a world that is literally being kneaded by the gravitational hands of its siblings, a constant, crushing friction that generates enough heat to melt the very rock beneath its surface. The first flags of this system came to us through the Transiting Exoplanet Survey Satellite, or TESS, a sentinel of light that watches for the rhythmic dimming of distant stars. To understand this discovery, we have to look at the methods we use to find worlds in the deep. There is the wobble method, or radial velocity, where we watch a star for the tiniest, almost imperceptible shake as a planet's gravity pulls it back and forth. It is the signature of a tug of war, a rhythmic pulsing dance that tells us how much the planet weighs. And then there is the transit method, the bread and butter of our orbital telescopes. This is the simple, elegant act of watching for the shadow as a planet crosses in front of its sun, a momentary dip in light that reveals the planet's size. In the silence of the Volans constellation, a small red sun holds a family of worlds that are rewriting the laws of planetary evolution. It is a system that challenges our understanding of where life can hide and where chemistry can thrive in the most extreme conditions. We are beginning to see that the neighbor next door is not a cold, quiet mirror of our own solar system, but a laboratory of fire and sulfur. But to understand the surface of the third planet, we must first understand the heat that screams from within, a force that dictates every breath of its atmosphere and every ripple in its molten oceans. The chemical heart of L98-59d exists within a narrow, violent window of the sulfur phase diagram, a realm where the familiar rules of geology are rewritten by the hand of extreme thermodynamics. On Earth, we know sulfur as a brittle lemon-yellow crystal, often found dusting the rims of volcanic vents or resting inert in a matchstick's head. However, as the temperature on this distant world climbs past 115 degrees Celsius, the solid lattice begins to fail, collapsing into a pale, watery liquid. But this is merely the beginning of the transformation. As the heat continues to rise toward the planetary average of 400 to 600 degrees Celsius, the molecular chains of the sulfur atoms begin to break and reform, turning the liquid into a viscous blood-red oil. It is a scale jump that defies our terrestrial experience, where the strike of a single match becomes a planet-wide ocean of brimstone. This is not a world of rock and stone. It is a world of viscous, flowing alchemy, where the very ground beneath your feet would be a shifting, liquid gold. The heat required to maintain this global ocean of liquid mineral does not come from a distant sun alone, but from a relentless process we call tidal kneading. As L98-59d orbits its M-dwarf host, it is caught in a gravitational tug of war, pulled and stretched by the star's immense mass. This mechanical stress literally kneads the planet's interior like a baker working dough, generating friction that melts the core and keeps the mantle in a state of perpetual agitation. This kinetic energy is converted into thermal radiation, fueling a network of volcanoes that never sleep and ensuring the sulfur remains in its liquid, deep crimson state. It is a world where the internal furnace is stoked by the invisible hands of gravity, creating a landscape that is both beautiful and terrifying. We are witnessing the result of a Schwarzschild of chemistry, where the physical properties of a simple element are pushed to their absolute limits by the sheer scale of planetary forces. The result is a molten sea that stretches from horizon to horizon, a literal ocean of liquid brimstone that serves as the foundation for this alien class of sulfur worlds. As the planet continues its rhythmic distortion, the surface tension of the molten sulfur creates vast, undulating waves that move with a heavy, honey-like slow motion. The atmosphere above it is thick with the stinging scent of sulfur dioxide, a byproduct of the constant volcanic outgassing triggered by the tidal kneading. This process is so efficient that it prevents the planet from ever fully cooling, creating a stable, high-temperature equilibrium that allows the sulfur to remain liquid for eons. Each pulse of the star's gravity sends a fresh surge of heat through the crust, manifesting as brilliant golden flares along the edges of the molten sea. To stand on the shore of such a world would be to witness the raw power of planetary physics, where the very substance of the ground is a fluid, energetic medium. The realization of a planet-wide ocean of liquid mineral brings a sense of profound awe, a reminder that the universe is capable of forging environments that are as alien as they are magnificent. This is the mechanism of heat, a silent, invisible force that defines the very essence of L98-59D. This heat does more than just liquefy the stone beneath our feet. It creates a structural paradox that shouldn't exist in a system governed by the harsh radiation of a red dwarf. When we look at M-dwarf stars like L98-59, we aren't looking at the stable yellow warmth of our own sun, but rather a volatile and temperamental host that frequently lashes out with solar flares of staggering proportions. For a planet as close as World D, these flares act like a persistent cosmic sandblaster, a relentless stream of high-energy particles designed by physics to strip away the gaseous shroud of any world unfortunate enough to be in their path. Conventionally, a planet of this mass and proximity should be a naked husk, a sterile ball of rock whose atmosphere was whispered away into the vacuum eons ago. Yet, as our instruments squint through the light years, they find something that defies this expected desolation. There is a weight to the space surrounding L98-59D, a thickness that suggests the atmosphere hasn't just survived, it is actively fighting back. The survival of this gaseous envelope points toward a chaotic subterranean resilience that we are only beginning to quantify. It appears the planet is saved by its own internal agony, as the constant tidal kneading from its neighboring worlds fuels a volcanic engine of unimaginable scale. These are not the occasional localized eruptions we see on Earth, but a global, systemic hemorrhaging of volatiles from the mantle. As the star's wind tears at the upper reaches of the sky, the crust below is constantly fracturing, spewing vast quantities of sulfur dioxide and carbon into the heights to replenish what was lost. The planet is locked in a desperate race, a struggle between the star that wants to strip it bare and the interior that refuses to stop exhaling. It is a cycle of atmospheric recycling that transforms the world into a self-healing organism, one that bleeds gas to keep from being hollowed out by the radiation of its sun. Trying to observe the surface through this protective layer, however, presents a new kind of frustration for our terrestrial telescopes. To look at L98-59D is to encounter a spectroscopic ghost, a silhouette hidden behind a veil so dense and chemically complex that it renders the planet's true face a mystery. The atmosphere is likely a thick, yellow-tinged haze of sulfur compounds, creating an environment where the light of the red dwarf is scattered and bruised until it reaches the ground as a dull, copper glow. It is like trying to see the flicker of a single candle through a thick, sulfurous fog. The data is there, but it is blurred, softened, and distorted by the very chemistry that allows the planet to exist. We see the fingerprints of sulfur in the light, but the details of the world beneath remain tantalizingly out of reach, obscured by the clouds of the planet's own making. This barrier of gas is the first great wall in our understanding of this system, a shield that protects the molten seas while simultaneously hiding them from our curious eyes. We find ourselves wondering how long such a balance can be maintained, or if we are witnessing a temporary state of grace before the star finally wins its war of attrition. But for now, the evidence suggests a defiant stability, a persistence of air in a place where there should be none. If the atmosphere holds against such impossible odds, it suggests a chemistry we have never seen in the wild, hinting at a world where the air itself is as much a product of the deep, molten interior as it is of the sky. This realization forces us to reconsider the golden reflections we've detected, leading us to wonder if the haze isn't just a barrier, but a mirror for the strange light of a distant sun. To truly understand the nature of this atmospheric shroud, we must look to the instruments that allow us to peer through the dark. The James Webb Space Telescope, with its massive gold-plated hexagonal mirrors, has provided us with a view that was previously impossible. By using the near-infrared spectrograph, or NIR spec, astronomers have been able to capture the light of the star L98-59 as it filters through the very edges of the planet's atmosphere during a transit. This process, known as transmission spectroscopy, allows us to see the chemical fingerprints left behind by the gases surrounding the world. As the starlight passes through the planetary limb, specific wavelengths are absorbed by the molecules present in the air, creating a barcode of sorts that tells us exactly what this world is made of. What Webb found was not the familiar signature of nitrogen or oxygen, but the unmistakable traces of sulfur dioxide and hydrogen sulfide. These sulfur compounds are not merely trace elements, they are the primary architects of the environment. On Earth, we are used to a world where water is the great mediator of chemistry, cycling through our oceans, our clouds, and our very cells. But on L98-59d, water is a rare gaseous ghost, a peripheral player in a much more alien drama. Here, sulfur is the dominant solvent, the engine that drives the planetary cycle. It is a world where the smell of the air would be the sharp, pungent sting of a volcanic vent, and the clouds are not made of fluffy water vapor, but of concentrated acid and elemental sulfur particles. Through the golden hexagonal mirrors of Webb, we are no longer looking at a dot. We are looking at a chemical engine that defies every Terran model. To make sense of these findings, researchers at the Max Planck Institute and NASA Goddard have had to move beyond theoretical math and into the realm of physical simulation. In specialized pressure chambers, scientists recreate the hellish conditions of these sulfur worlds, subjecting chemical cocktails to the same intense heat and radiation found 4 billion miles away. They watch as sulfur gases interact under high pressure, forming the same yellow-orange hazes that Webb detected. These laboratory comparisons provide the hard data we need to confirm that L98-59d isn't just a slightly hotter Earth, but a member of an entirely new class of planets. We are seeing the rise of the sulfur world, a place where the rules of planetary evolution have taken a different path, guided by the heavy hand of brimstone. This authority of data gives us a strange kind of comfort. Even in a place so alien, the laws of chemistry remain constant and observable. As we look closer at these golden reflections, we begin to realize that the geography of this world is even more unsettling than its chemistry. To step onto the surface of L98-59d is to abandon every earthly intuition regarding the permanence of stone. Here, the very bones of the planet are not composed of the familiar silicates or the jagged granite peaks we associate with terrestrial stability. Instead, the topography is defined by the fluid and the fleeting. The geography is a haunting collection of slumps, massive, rounded mounds of solidified sulfur that have oozed and cooled into soft, wax-like formations. Between these amber-colored highlands lie vast, impossibly flat plains of cooling lava, stretching toward a horizon that feels uncomfortably close due to the planet's compact size. It is a world that seems to be in a constant state of melting, a landscape where the ground under your feet possesses the unsettling consistency of cooling plastic rather than ancient rock. The sky above does not offer the familiar blue respite of a nitrogen-oxygen atmosphere. On Earth, Rayleigh scattering disperses shorter wavelengths of light, painting our firmament in shades of azure. But on this sulfur world, the chemistry of the air dictates a different palette. The atmosphere is thick, heavy with particulate matter that filters the light of the distant M-dwarf star into a suffocating ochre haze. To stand on L98-59d is to stand within a cathedral of copper light, where the wind carries the scent of ancient earth and the sting of acid. The sun, a dim reddish ember, struggles to pierce through this metallic fog, casting long distorted shadows across the yellow plains. It is a light that feels heavy, as if the brightness itself has weight, pressing down on the crystalline structures that define the horizon. Weather on this world is a phenomenon that challenges our very definition of the term. While we look for the movement of water to define our seasons, L98-59d experiences the sulfur weather. When the temperature dips even slightly, the saturated atmosphere reaches a breaking point. It doesn't rain in the way we understand. Instead, the sky begins to shed needles of solid yellow sulfur. These delicate crystalline structures drift downward like a toxic snow, a silent descent of chemical daggers that shimmer in the copper light. However, the reprieve is short-lived. As soon as these solids touch the surface of the molten sea or the heat-soaked plains, they hiss and vanish, melting instantly back into the liquid state from which they were forged. There is a profound, bone-chilling solitude to be found in this geography of brimstone. It is a magnificent landscape, one of terrifying beauty that remains utterly indifferent to the presence of an observer. We find ourselves looking at a place that is not merely uninhabitable, but fundamentally exclusionary to the chemistry of life as we know it. There are no echoes here, only the rhythmic thrum of the planet's internal heat and the soft, crystalline tinkling of the sulfur rain hitting the cooling crust. This is the isolation of the extreme, a silent, golden mirror reflecting a version of planetary existence that is as elegant as it is lethal. As we drift across these yellow plains, we realize that the planet's physical form is only a precursor to a much darker cosmic reality. But that's not even the strangest part. For while the geography is alien, the star that commands this world holds a secret that threatens the very stability of the ground we've just described. The star at the center of this system, L98-59, is a M-dwarf, a small and crimson furnace that operates on a timescale that truly breaks our brains. While our own sun is a middle-aged yellow star with perhaps 5 billion years of hydrogen left to burn, this red dwarf is a cosmic marathon runner, sipping its fuel with a frugality that borders on the eternal. Because it is so much smaller and cooler, the convective currents within its core constantly recycle hydrogen, allowing it to remain stable for trillions of years. To put that into perspective, by the time L98-59 finally exhausts its fuel and fades into a black dwarf, the Sun and the Earth will have been gone for so long that their very existence will be a forgotten ripple in the early history of the galaxy. This staggering longevity means that the sulfur world of L98-59d is not a temporary anomaly, but a permanent fixture of the local neighborhood. If the planet remains in this molten sulfur phase for 1 billion years, we must consider the slow, rhythmic evolution of its chemistry as the star eventually begins its long, multi-trillion-year cooling process. In the deep future, as the red dwarf's light shifts further into the infrared, the energetic input hitting the planet's surface will begin to wane, and the golden seas of liquid sulfur may begin to lose their fluid grace. However, the most profound physical constraint on this world is the tidal lock. Because L98-59d orbits so closely to its parent star, the gravitational tug-of-war has likely ground its rotation to a halt, forcing one hemisphere to forever face the searing red sun, while the other is cast into a permanent, bone-chilling night. This creates a planet of two impossible extremes, separated by a thin, jagged line known as the twilight ring. On the day side, the sulfur remains a roiling, viscous liquid, perhaps even vaporizing into a heavy, yellow haze. But as you cross the terminator line into the darkness, the temperature plummets instantly. In the shadows of the far side, the molten sea meets a frozen wasteland of solid sulfur ice, where the yellow plains become brittle, crystalline, and silent under the light of distant, indifferent stars. It is a landscape of transition where liquid fire meets a permanent frost, and where the atmosphere, if it exists, would freeze out and fall as yellow snow. While our Earth is a fleeting spark in the cosmic timeline, a vibrant but brief explosion of complexity, the sulfur world of L98-59d is a marathon runner built to endure for an eon. But longevity does not mean silence. It may mean a different kind of life. If we were to stand on the edge of this transition zone, we might find ourselves looking not for a reflection of Earth, but for an entirely new definition of biology. For decades, our search for life has been a search for water, the universal solvent that allows the dance of carbon to begin. Yet here on L98-59d, the sheer abundance of sulfur suggests a different chemistry altogether. In the high-pressure, high-temperature environment of this world, liquid sulfur, or even concentrated sulfuric acid, could potentially step into the role that water plays on our home planet. These alternative solvents possess the ability to dissolve a wide range of minerals and facilitate complex chemical reactions, perhaps acting as the medium for a life 2.0 that thrives in conditions we would find instantly lethal. It is a humbling thought to realize that the very substances we use as industrial cleaners or associate with volcanic desolation could be the lifeblood of an alien biome. On Earth, we have already seen a preview of this endurance in the dark, crushing depths of our own oceans. Near hydrothermal vents, where the sun's light can never reach, entire ecosystems exist that have completely decoupled from photosynthesis. These organisms rely on chemosynthesis, drawing their energy directly from the chemical bonds of hydrogen sulfide and other volcanic minerals. On 98-59d, this localized phenomenon is scaled up to a planetary level. In essence, the entire planet functions as a global hydrothermal vent. There is no need for a sun to drive the gears of this biology when the internal heat of the world and the chemical richness of its crust provide a continuous, multi-billion-year feast. The true engine of this exotic biome, however, lies in the energy gradient created by the planet's tidal locking. Between the eternal furnace of the day side and the bone-chilling cold of the night side, there exists a massive thermal imbalance. In physics, such a gradient is essentially a planetary-scale battery, a flow of energy that complex structures can tap into to maintain order against the pull of entropy. We are searching for ourselves among the stars, but L98-59d whispers that the universe may have designed something far more resilient than us. This world suggests that life is not a fragile accident of a perfect garden, but a persistent, inevitable pressure that will find a way to manifest even in the heart of a sulfurous machine. As we look at these golden oceans, we are forced to expand our vision, recognizing that the cosmic architecture of life may be as varied as the stars themselves. This realization leads us toward the subtle, almost unsettling shadow of the anthropic principle, a concept that suggests our view of the universe is inherently biased by our own existence. We look out into the blackness and seek blue marbles, worlds of nitrogen and oxygen with gentle rains of liquid water, because that is the only environment we have ever known to support life. We assume we are the cosmic standard, the baseline for what a successful biological experiment looks like. Yet, as we stare into the golden sulfurous haze of L98-59d, we must consider a humbling alternative. Perhaps we are the anomaly. It is possible that the vast majority of life in the Milky Way resides not on fragile, water-soaked rocks, but within the thick, protective embrace of sulfur worlds. In this light, Earth becomes a rare and precarious exception, a garden world balanced on a knife edge of specific chemistry, while the rest of the galaxy teems with organisms that would find our oxygen-rich atmosphere to be a corrosive, freezing poison. However, if life truly thrives in these molten oceans, it faces a technological barrier that might explain the deafening silence of the Fermi paradox. Imagine a sentient consciousness evolving within the liquid brimstone of L98-59d. For these beings, the environment is a constant, high-pressure furnace. On Earth, the discovery of fire was the first step toward the stars, allowing us to forge metal, create steam engines, and eventually manipulate electricity. But how does one discover fire in a world where everything is already burning? How do you forge a spear or a circuit board when you live in a medium that melts most conductive materials? To a creature in a sulfur sea, the very concepts of dry or cold might be as alien as four-dimensional space is to us. Without the ability to manipulate fire or smelt ores, a civilization could reach a plateau of profound social and biological complexity, yet remain forever trapped beneath their thick yellow clouds. They would be masters of their world, yet entirely unaware that a universe of stars exists beyond the haze. This brings us to a sobering thought about the Great Filter, the hypothetical wall that prevents life from becoming interstellar. Perhaps the filter isn't a nuclear war or a natural disaster, but simply the chemistry of the birth world itself. A planet like L98-59d could be a cradle that never becomes a launch pad. We often wonder why we haven't heard from anyone else, searching the radio waves for a signal that never comes. Perhaps the galaxy is teeming with life that is content to remain in the warm, golden embrace of its own world, never looking at the stars at all. They might lead lives of deep meaning and intricate beauty, blissfully ignorant of the vacuum above them. They are not hiding, they are simply satisfied. It is a perspective that requires a deep, quiet humility on our part. We are the restless ones, the species that looked up and saw a frontier instead of a ceiling. But in the grand celestial clockwork, our drive to leave the nest might be the strangest thing about us. We are the data point that refuses to stay in the liquid warmth, venturing instead into the bone-chilling cold of the void. Leaving the cold behind, we descend once more, drifting through the upper reaches of the L98-59d atmosphere, where the copper-colored clouds begin to thin and part. The air here is thick with the scent of ancient chemistry, a heavy metallic haze that glows with the reflected light of a sun that never moves. As we sink lower, the turbulence of the upper winds fades into a profound, heavy stillness. Below us, the golden ocean stretches out toward every horizon, a vast expanse of molten sulfur that ripples with the consistency of warm honey. There are no crashing waves here, only the slow, rhythmic swelling of a world that is perfectly synchronized with the gravity of its parent star. It is a sea of liquid fire, yet it feels strangely serene, a cradle of heat that has remained undisturbed for billions of years. The planet breathes with a slow and steady cadence. From the deep fissures in the crust, plumes of gas rise in a silent, synchronized pulse, mirroring the internal heartbeat of the core. Every few minutes, the surface of the sulfur sea rises and falls, a tidal surge driven by the invisible hand of the nearby sun. This is the rhythm of a world that has reached a state of ultimate equilibrium. There is no weather here in the way we understand it, no seasons to break the long golden afternoon. There is only the constant, low-frequency hum of the planetary machinery, the sound of stone shifting against stone, and the soft hiss of heat escaping into the dark. This heat is not an isolated phenomenon. It is a direct descendant of the very first moment of time. The energy that keeps the golden ocean liquid is the same energy that was once compressed into a single, infinitesimal point of infinite density. It has been stretched, expanded, and cooled across 14 billion years, yet it remains the primary driver of all existence. In the heat of L98-59d, we are seeing a variation of the Big Bang, a localized pocket of the same fundamental force that once ignited the first stars. The universe does not make mistakes. It only makes variations on a theme of light and heat. Beneath the red sun that never sets, the golden sea is calm now. The storm of discovery has passed. Our journey into the molten interior of this world has reached its conclusion, leaving us with a sense of profound, quiet peace. The horizon is a dark line against the glow of the sulfur, a boundary between the warmth of the planet and the eternal cold of the void. As we drift above the surface, the pulse of the tides begins to feel like our own, a steady and reassuring heartbeat that echoes the deep, rhythmic breathing of the cosmos itself. There is nothing left to solve, and no mysteries that need to be unraveled tonight. We have found a world that is content to be exactly what it is, and in doing so, we have found a strange kind of peace. This golden sulfurous horizon of L98-59d, once a place of violent volcanic upheaval and crushing atmospheric weight, now settles into a singular, unmoving point of focus in the mind's eye. We have spent this time navigating its rivers of molten rock and its heavy, yellowed skies, trying to reconcile such a foreign landscape with our own understanding of what a planet should be. Yet, as we prepare to leave this world behind, a profound realization begins to take hold. While this place is alien in every sensory detail, it is not a violation of nature. It is, instead, a confirmation of it. The same gravity that pulls the liquid sulfur into low, heavy waves on this distant shore is the very same force that holds your own body to the surface of the Earth. The thermodynamics that govern the cooling of these volcanic plains are the same laws that allow a cup of tea to cool on a nightstand or a hearth to radiate warmth across a room. There is a deep, structural comfort in knowing that the universe uses a consistent set of rules to build its most diverse creations. This world, as strange as it may seem, is governed by the same physics that keeps your heart beating in its steady, quiet rhythm. It is a part of the same grand design, a different verse in the same long, ancient poem. As we begin our ascent, the golden glow of the sulfur seas starts to soften. We are no longer standing on the scorched crust. We are lifting away, rising through the thick, hazy layers of the atmosphere. The pressure that felt so immense only moments ago begins to thin and dissipate. The heavy yellows and deep oranges of the sky fade into a pale, translucent amber, and then, quite suddenly, into the absolute, velvet black of the vacuum. Looking back, L98-59d is no longer a world of terrifying heat, but a small glowing marble suspended in the dark. It is a solitary lantern in the deep, its molten surface shimmering like a dying coal in a vast, dark forest. We see it now for what it truly is, a tiny, fragile pocket of activity in an ocean of stillness. The volcanic plumes that seem so massive from the surface are now invisible, reduced to microscopic flickers of light. The planet is shrinking, becoming a mere data point in the local system, a silent witness to the passing of eons. We drift further out, passing the sister worlds of the L98-59 system. We see the inner rocky worlds, bathed in the fierce radiation of their host star, and the outer reaches where the light grows dim. These planets, each unique in their composition and their history, are like pearls scattered across a dark table. They move in their predictable, elegant orbits, governed by the invisible hand of the star's gravity, performing a celestial dance that has continued for billions of years without interruption. There is no noise here. There is no wind to carry the sound of a volcanic eruption, no atmosphere to vibrate with the hum of a tectonic shift. There is only the near total absence of everything, a vacuum so pure and so vast that it swallows all sound and all fury. We are moving past the edge of this solar system now, leaving the warmth of the central star behind. The light of L98-59 begins to blend with the light of 1,000 other suns, losing its individual identity and becoming part of the general glow of the Milky Way. We are entering the interstellar void, the great, cold corridors that exist between the islands of light. Here, the distances are so great that the mind can no longer find a terrestrial anchor to hold onto. We are traveling through the kind of distance that breaks our brains, where light itself takes years to cross the gap from one neighbor to the next. In this space, there is nothing but the faint, ghostly presence of the cosmic microwave background, the lingering whisper of the Big Bang that permeates every cubic centimeter of the universe. It is a bone-chilling cold, a temperature so close to absolute zero that time itself seems to stretch and slow. Yet, in this emptiness, there is no fear. There is only a sense of profound, undisturbed equilibrium. The vacuum is not a place of lack, but a place of perfect potential, a quiet field where the laws of physics rest in their most fundamental state. We are drifting in the ultimate heat sink of the cosmos, where all energy eventually seeks to find its balance. As we zoom further out, the individual stars begin to cluster together, forming the majestic, spiraling arms of the galaxy. From this perspective, the life and death of a single planet like L98-59d is a fleeting event, a blink in the eye of the cosmos. Entire civilizations could rise and fall, seas could boil away and freeze back into ice, and stars could exhaust their fuel and collapse into white dwarfs, all within the span of a single galactic rotation. This scale does not diminish us. Rather, it invites us to let go of the small, temporal anxieties that occupy our waking hours. When compared to the span of 1 billion years or the breadth of 100,000 light years, our burdens become weightless. We are stardust in our veins, a small part of the universe that has developed the ability to look back at itself and wonder. We are the universe experiencing itself, and tonight, that experience is one of absolute, unshakable tranquility. If you found peace in this journey across the golden seas and out into the silent dark, I would be grateful if you joined us for our next exploration into the unknown. There are many more worlds to visit, many more mysteries to peek under the kilt of, and many more nights where we can lose ourselves in the elegant mathematics of the stars. But for now, do not worry about the next destination. Do not think about the physics of tomorrow or the distances of next year. Let the sheer scale of the cosmos carry you away, drifting like a silent probe through the ink-black waters of the deep. Your journey for today is complete. The data has been gathered, the observations have been made, and the light cone of your experience has expanded just a little bit further. The stars are distant, far beyond the reach of any human touch. The sea on L98-59d is golden, glowing with a heat that we can only imagine from the safety of our own quiet rooms. The universe is, as it has always been, perfectly at rest, moving through its grand cycles with a patience that exceeds our comprehension. There is a clockwork precision to the way the galaxies turn and the way the atoms vibrate, and you are a part of that precision. You are tucked safely within the folds of space-time, protected by the same laws that govern the furthest quasar and the smallest particle. There is nothing left to do but surrender to the rhythm of the drift. Let the darkness be your blanket and the distant light of the stars be your guide into the long, silent night. The universe is watching over its own, and all is well in the great, infinite dark. The stars are distant, the sea is golden, and the universe is, as it has always been, perfectly at rest. Good night. Consider the quiet symmetry of your own breath, and how it mirrors the expansion and contraction of the nebulae we have witnessed tonight. Within your body, the same chemical bonds that hold the sulfurous clouds of L98-59D together are currently conducting the signals of your thoughts and the rhythm of your resting heart. We are not merely observers of this golden, molten world. We are made of the same fundamental constants, the same universal properties that allow a planet to persist in the searing heat of a red dwarf. The iron in your blood and the calcium in your bones were forged in the same high-pressure crucibles of ancient stars that once populated this sector of the galaxy. There is a profound, silent comfort in knowing that the laws of thermodynamics and the curvature of space-time do not change, regardless of how far we drift from home. As we begin to pull away from the glowing horizon of the sulfur world, the golden ocean shrinks into a singular, brilliant point of light. We move past the inner rocky worlds, those silent sentinels of the L98-59 system, and enter the vast, cold corridors of the interstellar medium. Here, the density of matter drops to almost nothing, a near-perfect vacuum where the only travelers are stray photons and the occasional hydrogen atom. This is the great quiet, the background radiation of the universe that hums with a frequency lower than human hearing can detect. In this space, time loses its urgency, and the distances between the stars become a soft, dark fabric that cushions the mind. You are drifting now, suspended in a state of weightless curiosity, where the heavy concerns of the day are replaced by the slow, majestic rotation of the Milky Way. If you found peace in this journey through the golden mists and the molten tides, I would be grateful if you joined us for our next exploration into the unknown. We have so many more light cones to enter, so many more mysteries to observe from the safety of our collective understanding. But for now, let the sheer scale of the cosmos carry you away into a dreamless state of receptivity. The heat of the molten sea is a distant memory, replaced by the cool, comforting embrace of the infinite drift. There is no more data to process, no more physics to calculate, and no more questions to answer. The universe is, as it has always been, perfectly at rest, and you are exactly where you are meant to be in the celestial clockwork. The stars are distant, the sea is golden, and the universe is at peace. Good night.